In this video, we're looking at ENGAA 2020, Section 1, Question 34. So, we have an equation here, y equals x cubed plus 3 root 5 px squared plus 3px plus 13. And we're told that it has two distinct turning points. And we're asked what are all possible values for p. So, where shall we start? Well, we know that our equation has two distinct turning points. So, what does that mean about our expression? Well, it means the gradient, or the dy over dx, when we differentiate it, that's going to have two real roots. If we find that equation will have two real roots. So let's start from there. Let's find dy dx of this equation here. So take a second to work that out. So we're going to have 3x squared plus 6 root 5 px plus 3p. So all we're doing is timesing our coefficient by our power and then decreasing the power by 1. That gives us our equation here. And then we can set this equal to 0 because that's going to have our that's going to be our turning points when the gradient is 0. So we know it has two real roots. How do we know that? What can we use to find p, knowing that it has two real roots? Well, we can use the discriminant. When our discriminant, b squared minus 4ac, is larger than 0, that means that we have two real roots. So let's use this on our equation we just worked out to find p. So our b is going to be our coefficient for our second term, our a is our coefficient for our first term, and c is for our last term. So we've got 6 root 5p squared, take away 4 times 3 times 3p, and that's all larger than 0. Let's expand these brackets. We're going to have 180p squared, take away 36p, and we can now factorise this. So we're going to have p times 180p, take away 36. So now let's solve this for our values of p. Well, we're going to have p being 0 and 180p minus 36 being 0. That's 180p equals 36, and p being a fifth. But these are going to have to be inequalities. As we know here, we've got an inequality symbol. But which direction do they go in? Well, to help us, let's draw our graph. So here we go. We've got our points here, our turning points, a fifth and 0, or our real root, of our gradient equation. And we're looking for this to be larger than 0. So we want it anything above this line here. We don't want this bit in the middle. This is less than our 0. We want these bits here. So that's going to correspond to our being less than 0, or this line is less than 0, and being larger than a fifth. So our answers are going to be p is less than 0, or p is larger than 0.2, which is equal to a fifth. So our final answer is answer A.